Okay, welcome everybody. I'm Sebastien Deleuze. I work for Pivotal. I'm a committer on the Stream framework, specifically on the web, Kotlin, and reactive topics. And today we are going to see why Spring love Kotlin. So today is the most popular way to build web application in Spring Boot and Java. And we are going to see how far we can go with Spring Boot and Kotlin. And we are going to talk about official Kotlin support I announced at the beginning of the year. This announcement get a huge feedback, a lot of retweets, a lot of comments, a lot of people that were quite happy about this move. So since January, we have continued to improve the support, polish things. We have received a few major contributions, and we are going to detail all these new features today. To do that, we are going to use a sample Spring Boot blog application. That's a regular application developed with Spring MVC and Spring Boot and Java. And we are going to gradually migrate it to a fully idiomatic Kotlin and Spring Boot 2 application. So we are going to change just the language, migrating from Java and Kotlin. And in this first step, we are not going to take advantage of any Kotlin-specific support, so just changing the language. Then we are going to switch from Spring Boot 1 to Spring Boot 2. Spring Boot 2 is based on Spring Framework 5, and it provides dedicated support for Kotlin, while Spring Boot 1 does not provide anything specifically for that. The third step will be migrating from Spring MVC to the new Spring WebFlux web framework. I'm going to detail that a little bit later. That will be with the annotation-based variant. And then we are going to use the new functional API and the Kotlin DSL. The last step will be using Kotlin instead of JavaScript for the front end. So let's start by converting our application from Java to Kotlin. So the easiest way to start a Kotlin project with Spring Boot is to use start.spring.io. If you have heard Josh yesterday, you have learned this address, I hope. You can use this shortcut with language equals Kotlin to directly go to this page with the Kotlin language already selected. So if you want to share an address with your colleagues, that's that one. We have added this support for the release of Kotlin 1.0. And we continue to maintain it by releasing and updating a new version with the latest Kotlin version. So yeah, you can count on us to get that supported. When we first started to build Spring application with Kotlin, there was a few pain points. One of them was that we were forced to use open keywords at class and method level, because in some places, we need at Spring level to extend dynamically at runtime the classes and the methods. That's, for example, for the add configuration classes, for transactional support. So we discussed with the Kotlin team, and they released a compiler plugin which automatically opens any classes or method annotated with the Spring annotation, and that also supports the meta annotations. That means if you are a custom one meta annotated with add component, for example, it will be taken in account by this plugin. Obviously, when we convert a Java application to Kotlin, the first thing is that we have much more concise code. So you can compare. I am not the place to put all the Java code, so it go until the floor. Literally. It's not really about writing faster, because we all have IDEs that allow to generate code very fast. But when the time comes to maintain, to debug, to read someone else's code, or even new code sometimes after, I prefer to maintain the Kotlin version, obviously. Also, Kotlin design pushed to use immutable properties, while in Java we are more naturally using domain model classes with mutable properties. So yeah, that's an easy one, but that's obviously a good feature. This is a regular Spring MVC controller written in Java. So you can see that we are using constructor-based injection. Since there is a single constructor, it will be automatically auto-wired. And the Kotlin version is that one, so you can see that's more concise. We still take advantage of the constructor-based injection, and I would say that's even more a best practice in Kotlin, because we try to have non-nullable properties or fields. So yeah, except for test, use constructor-based injection as much as you can. We leverage type inference to have a concise code. So I'm not forced to repeat the types everywhere. No need for the public keyword because that's the default. And yeah, that's pretty much the same thing with shorter code. Some people are complaining, mostly when they come from the Java world, that maybe in some sense it's less readable because you don't have the type. So be aware that that's not enabled by default, but you can display type ints in ID. So you go to Settings, Editor, General Appearance, show parameter name ints, select Kotlin, and then you can check function, property, and local value return type ints. And that will display in your IDE the types. That's pretty nice when you are reading the code, and I usually enable that. Kotlin allows to write expressive test name, so the emoji are optional, but the key point is that you can write expressive test names to write a clear sentence about what this test is about, and that's supported by default. You can use it even with JUnit 4 or any kind of testing framework. So don't hesitate for regular production code in your SRC main. I would not recommend that, but for tests, using this kind of very expressive sentence is something that helps for expressiveness of your test. Now, we are going to migrate to Boot 2. So Spring Boot 2 leverage Spring Framework 5, Spring Data K, and provide official support for Kotlin. So when I say that Spring loves Kotlin and officially supports it, I'm not talking just about framework. I'm talking also about various projects in the Spring ecosystem, Reactor Core, Spring Data Key, Spring Boot 2, and we even have a start of specific support in Spring Cloud Gateway. So really, we try to support as much as we can Kotlin in the various parts of the ecosystem. It has started from Spring Framework 5, and then it's propagate in other projects. Our strategy is to support Kotlin by default. I mean, there is no additional Kotlin extension jars. The Kotlin bytecode is directly integrated into Spring Framework, Spring Boot, Spring Data K jars. So when you are using Kotlin with Spring, it's supported by default, and we automatically enable Kotlin-related feature when Kotlin is on the class path. So the extensions that we provide for Spring API, the DSL that we provide are literally in the regular Spring jars, and you just have to use Kotlin to take advantage of them. I have spent a fair amount of time to write the documentation, so please read it. I have tried to put a lot of things in it. You will see that's a pragmatic documentation with a lot of links to open issues and things like that, so I will continue to maintain it to make you informed, because there is some pending issues that need to be fixed on Kotlin side, for example. But yeah, most of the feature supported in our Kotlin support are referenced and documented here. There is also a Kotlin API documentation. So the philosophy, since Kotlin has very good interoperability with Java, Kotlin API is the Java one, plus additional extensions method that we have added to provide more Kotlin-specific feature when that made sense, and also additional DSL. So the Kotlin-specific API are documented via Docker and available with this URL. So this is a regular startup of Spring application with Spring Boot 1. You can see that we have, so that's very short, obviously. We take advantage of the fact that Kotlin supports top-level function. But you can see that we are using ::class.java, which is not super idiomatic. So with Spring Boot 2, we are providing a new top-level function which is run application, we take advantage of the Reified type parameters, and you just specify the class of your application, and that's it. When you want to add additional beans, like in Java, you add a body to the application class, and you specify add beans, leveraging the type inference. And if you want to customize, for example, I don't know why you will make that, but remove the banner, for example, you can use this lambda. So we have made run application extensible, and you can use it to customize the Spring application. We provide various extensions of Spring Framework API, and I won't detail everything today. But for example, we provide this kind of array-like Kotlin extension for the model. So we ship directly this Kotlin code. So you can see we provide an extension to model where we add a set operator, which directly call add attributes. We ship that into Spring Framework jars. And when you are writing your Spring MVC view, you can use this nice array-like syntax in your Kotlin code. Just a warning, I guess you are already aware of that, but extensions need to be imported before being used. IDE does a pretty good job to propose you most of the extensions. Sometimes they are not proposed automatically, but that's just a matter of time to get that working perfectly. More interesting extensions are leveraging the Reified type parameters from Kotlin into Spring API. And we have added a few extensions like that into the various parts of the API. So the syntax of the extension is a little bit obscure, but basically in Java, there is, I have taken the most horrible example. But in Java, because there is type erasure, to be able to retrieve a list of something with the REST template, you have to write this not so nicely looking code, okay? And with Kotlin, since we can get generic type parameters at runtime, we have been able to leverage that with this little extension to make it possible to just write REST template.get for project. You specify as many as nested generic level that you want, and that's all taken in account. I guess it's much better. So we provide this kind of extension for REST templates. Also in Spring Data, so Spring Data K provide by default a built-in Kotlin extension. So for example, if you are using Mongo template or Mongo operations, it is also provided. And if you find places where you think it should be nice to take advantage of this mechanism and that's not available, please create an issue or submit a pull request, and we will integrate it. Another thing that we have done is to leverage the Kotlin nullable information. So in Java, the nullability of a type is unknown, so you have to guess it or to read the Java doc. In Kotlin is specified in the type system. And in some places in Spring Framework, we leverage that information. So we use Kotlin reflection to understand and know what is the nullability of a parameter. And we use that to infer the required attribute of some annotation. So for example, auto-wired has a required annotation. So here it is not displayed, but it is implied because there is a single constructor. So if it's like if the constructor was auto-wired. And we take advantage of that to know that foo is mandatory. So there must be a foo bin in the context. Otherwise, we will raise an exception. And bar is nullable. So we automatically automatically implies that the required attribute is to false. And then if there is a bin of bar type, it will be injected. If there is none, we will just inject null and not raise any error. That's the same for request param. So request param has a required attribute that need to be specified to false in Java if you want request param to not be mandatory. And in Kotlin, if you annotate a nullable parameter, it will be automatically considered as not required. The null safety of the Spring API has been a very big effort because when you use the Java framework from Kotlin, you will notice that you get this strange exclamation mark that's in return values and parameters That means Kotlin doesn't know the nullability of this parameter or this return value. So in practice, he won't force you to put too much null checks. They did that in the first version of Kotlin, but they removed that. But the drawback is that you could have a null pointer exception when using Kotlin with Spring API because the null safety is unknown. And Java has not that. So what we have done, and we have worked a lot with JetBrains about that, we have introduced null safety annotations everywhere in the Spring Framework code base and everywhere in the Spring Data code base. So that's a lot of work. To specify at package level with this @non-null API, which is annotated with GSR 305 annotation. That means this annotation could be understood by the tooling without any specific Spring support, if the tooling support that, but ID and Kotlin support that, and maybe later Sonar will support that as well, I hope. That means that by default, every parameter and return value are considered as not null. That means Kotlin and ID will consider that as non-null types. And when we have a return value that is nullable or a parameter which is nullable, we explicitly annotate it with @nullable. And we have done that in all the Spring Framework API, all the Spring Data API. It works pretty well. It's taken in account by Kotlin in the latest version. The missing parts are generic type arguments, null safety, and also array and varargs elements, null safety. We are working on that to provide that maybe in Spring 5.1. We work on that with JetBrains. So null safety is a long journey. I think that's super valuable to get rid of the null pointer exception and to deal with nullability at compile time. And we are almost OK. So yeah, I think that's a good thing. You need to enable that in your configuration. So have a look to the documentation. You have to specify to enable the strict mode to make it possible for Kotlin to interpret that as a null safety. But if you do that, be aware that we may slightly adapt the null safety annotation because we may have made some mistakes. So it could break your API. So if you just put that as a warning, your application will not break. If you put that in strict, which is pretty nice, be aware that we could change slightly the null safety annotations. Now, yeah, the remaining pain point. That's the main one, I think. We have done the maximum to remove all the pain points. This one still remains, but hopefully will be fixed before Spring Boot 2 release. It's about configuration properties. There is various ways to deal with configuration properties. You can even use @value, but in Kotlin, the $ is already for string interpolation, so you have to escape it. That's not super nice. And since Kotlin is about providing some statically typed experience, I think configuration properties is a much more suitable thing to use with Kotlin. Sadly, when you use that currently with Spring Boot 1, you ended up with a lot of nullable values because basically that does not play well currently with Spring null safety. And in your code, you have to put exclamation mark to avoid that, and that's not that great. So there is two possibilities to fix that in Spring Boot, and they have been both discussed. The first one is to use interface. The second one is to use data classes. You can have a look to the issue I mentioned to understand why it is not so simple to use data classes to support that. So I don't think that will be supported that way in Spring Boot 2, but we may support that with interfaces, which lead to pretty nice code. So basically the ID, and that's not yet implemented. So, but hopefully that will be the case before the GA. We use an interface, and we can just use val with non-nullable types, and that will work as expected, and that will map you YAML or application properties to something that is statically typed. And basically, under the hood, Spring Boot will create an implementation of that interface. And from a code point of view, you have an immutable interface implementation behind that. So I think that will be pretty nice. I think that's the most annoying remaining issue when you are building a Spring Boot application. So we will do our best to fix that. That's not directly in Spring, but we provide in Spring Boot 2 and Spring Framework 5 support for JUnit 5. And JUnit 5 supports non-static at before all and at after all methods, annotations, excuse me. That's super useful for integration test because with JUnit 4, you have to have this method static. So in Kotlin, you have to put companion object, and that's not that great. So JUnit 5, when you enable the per class lifecycle, because by default, JUnit instantiates the class for each test. That's the behavior by default. JUnit 5 adds the possibility to instantiate your test one time per class, and I personally prefer that behavior. So you can enable that via JUnit-platform.properties. You can have a look to the Spring Framework documentation. I have put the more details, or with an annotation. And that will allow you to just annotate at before all, at after all on a regular method that read pretty well, and even your test may be faster because there is just a single instantiation. Just be aware to not modify the state of your classes and things like that. JUnit 5 also allows to write specification-like tests. There is some specification test frameworks like Spec, for example, but it's pretty great, but it has, in my opinion, some limitation about tooling support, about integration test, about support of Spring. So I tend to think that JUnit 5 plus Kotlin are a good bet because it supports nested classes to write this kind of specification-like test. You can use expressive function name with backticks, and you ended up with pretty nice specification-like test capabilities. So yeah, feel free to try it. That works pretty well from my experience. This is an experimental feature that Josh showed yesterday. Congrats to do that in live coding. There is some possibility to use Kotlin as a template language. So basically, Kotlin provides Kotlin script support, and we can use that. So in this example, you can see that I'm using multi-line strings, which is another Spring functionality, plus a string interpolation to basically build a templating system that supports internationalization and template includes. I say it's experimental because it requires a lot of ceremony to set up that, because that's based on the generic GSR 223 support. I have implemented in my example a quick cache mechanism because Kotlin script is quite slow to compile, so you really need to have caching if you want to go to production. So I think everything is available to make something more integrated. So if you want to provide a more first-class support for that, I mean, every pieces are available. Feel free to contribute such a module. But yeah, currently that's experimental, but you can write pretty nice templates with Kotlin, and the advantage is that you don't have to learn a new template language. There is so many. So now we are going to switch from to WebFlux with the annotation programming model. So Spring Framework 5 comes with two web stack, Spring MVC, which was existing in Spring Framework 4. It's blocking, so blocking is not a bad word, okay? Blocking applications are perfectly fine for a wide range of use case. It's servlet-based. That means the servlet API, it is really based in a mandatory way on servlets, specification and API. But we introduced in Spring Framework 5 a new framework called Spring WebFlux, which is non-blocking, which leverages Reactive Streams and can run on Netty, Servlet 3.1, so Tomcat, JT, Undertow, and I guess other engines will come. So that's a new web framework. The use cases to use it are scalability. You are not limited in terms of concurrent threading on concurrent threads. Streaming, latency, so when you build microservices application that need to request remote web services, for example, this kind of use cases. Yeah, I think that's the main use case. You can also, since we provide a functional programming model, just the style of programming could also be an incentive to use it. We will detail that just after. The foundation are Reactive Streams. So Reactive Streams is a specification. We have worked on Pivotal with Lightband, Netflix, and a few other to define how a publisher and a subscriber exchange data in a non-blocking way. And the specific point about Reactive Streams is back pressure. So back pressure is a mechanism that basically implies that the subscriber is going to subscribe to the publisher, and then nothing happens, no data is exchanged. The subscriber has to request some data, so it will request 1, 2, 3, 10 elements, and then the publisher will send the elements. So the publisher will never send data if the subscriber has not asked this data, and that allows basically to fine-tune the amount of in-flight data between a subscriber and a publisher. So imagine if you have a very fast publisher and a slow subscriber, the subscriber will not be overwhelmed by too much data because he will only request the data at the speed where he can process it. And you can obviously choose what you do when you request, you have some back pressure exception, you should drop it, buffer, etc. So that's also a way to control the amount of memory that you are using for this kind of transfer. You can have infinite streams. You can have just one value. You can have no value. You can have a finite elements size. So that's a kind of async collections. And reactive streams exchange can be complete with an error or a complete event. So that's the foundation of WebFlux. But at the application level, which interests you, you can use whatever async type you want. Completable future, flow publisher, because Reactive Streams has been integrated into Java 9. Eric Java 1, Eric Java 2, Reactor, Aka Streams, or any other Reactive Streams-based API. So the core of WebFlux is based on Reactor because we need reactive implementation to build WebFlux because Reactive Streams does not help, does not provide any operator, but you can use whatever API you want. So a quick look on Reactor. Reactor is composed of two main reactive types, Flux, which is a publisher, a Reactive Streams publisher of 0 to n elements. That's close to Eric Java 2 Flowable. It provides a wide range of operators, and we have tried to keep the name of a reactive extension. So if you already know Eric Java of any reactive extensions implementation, most of the API is OK. We have just changed some horrible name like AMB, which is first emitting in Reactor. We provide also Mono, which is also a Reactive Streams publisher for 0 to 1 elements with a specific API that only makes sense for single elements. And it can be used, for example, classical use case, you have to request a streaming API like the Twitter one. So we provide a client and a server. Client is super important in WebFlux, much more than in Spring MVC. You can request with the WebFlux client a regular REST API, and you use reactive operators to merge the data and publish it as server-sent event or WebSocket. So that's specifically done for that. Reactive API are functional, so that implies that you change the way you express your code. So instead of doing imperative programming, you are building your reactive pipeline, so you are just describing the various transformations that will occur, and then something triggers the processing. In that case, that's a subscribe method. So that changes the way you develop. We provide Kotlin extensions in Reactor. So instead of writing mono.just, we have added an extension method that allows to transform any object in Mono. The same for Flux from iterable, list, streams, etc. We can also transform exceptions to publishers that trigger an error. And also, you can see the last example. A difficulty in Java is that the reactive API are fluent, and basically you can't extend them. You can't add operators. So the nice thing with Kotlin is that with the simple extensions, we can, in that example, we can use an average extensions to Flux. And the nice things about extensions is that they can apply only on specific generic types. So for example, average extension will be available in Flux of int, but not in Flux of string. So that's a pretty nice way to extend a reactive API. When you are using Spring WebFlux with annotation, we have tried to reuse as much as we can the Spring MVC annotations. So, but you will have to use reactive repositories. So We provide Spring Data Key with reactive support and API with MongoDB, Redis, Cassandra, and Couchbase. That means this Spring Data reactive variant will expose API with Mono and Flux, and you can directly use that in WebFlux. So now about coroutines. So coroutines are lightweight thread. We have talked a lot about that in KotlinConf this year. From a Spring point of view, I think the main use cases are writing non-blocking application while keeping the imperative programming. I have said just before that when you use the WebFlux, a new framework, you have to change the way you develop, and a lot of people like functional programming. That's super powerful. But for some people used to imperative regular programming, it's also just a matter of taste. You may prefer imperative programming, and that's perfectly fine. Coroutine may be a way to keep your favorite programming model, imperative programming model, while leveraging all the reactive infrastructure we are currently building on Spring Data, Spring WebFlux, etc. The other use case is also creating new operators for Reactor, because creating new operators in Reactive API is super hard. So usually when I need that, I ask to Stéphane Maldini or Simon Basselet to do that from the Reactor team. And with Coroutine, you can easily create custom operators, and with Kotlin extension, you can easily plug these new operators to the Flux or the Mono API, so that's also a good use case. Kotlin's coroutine library provides support for Reactive Streams and Reactor support. So Mono will translate to a suspendable function of nullable of t. Flux will translate to receive channel if that's a stream, or a list, suspendable list, if that's more like an asynchronous collection. And Mono void will just translate to a suspendable function that just return unit. So we don't have any official support yet in Spring Framework, because that's too early. Conrad, which did an amazing work, so congrats to him, did a very good talk just before mine about that. So if you didn't have a look, please have a look to the video. So currently, it's community-driven. We are carefully evaluating it. Coroutines are still experimental. There is a wide range of questions about transactional support, about backpressure interoperability. We need to benchmark performance. So yeah, we don't want to go too fast. So current status here is we are evaluating that to see if we integrate or not that as an official Spring support. So with Coroutine, our controllers and data repositories look like barely the same than with imperative programming, but you can see that we just add the suspend keywords, and that will do the job. So that could be interesting, and that's something we want to have a look. But yeah, we need to see if there is issues with backpressure and other things like that. So we were in the annotations world, but you have noticed that reactive APIs are functional, and you may be tempted to use more functional code in your Spring application. So WebFlux come in two flavors: annotations with the programming model very close to Spring MVC, and also with a new functional API, which is available in Java. And in Kotlin, we provide some facilities to use that. And some people may think that that may be more idiomatic to use this kind of API rather than the annotation-based one. It's a matter of taste. Use what you want. It's your choice. Spring WebFlux functional API is based on these three building blocks. So we have router function and handler function on server side, and we have web client for the client side. So really, a key difference is that the client is a first-class citizen in WebFlux. And since when you are building microservices application, you are going to use both equally servers and clients and chain them. The web client is powerful. It provides a fluent API. So feel free to have a look. So this is a WebFlux functional API with the Kotlin DSL. That's quite different to what you are used to with annotations. You can see that, so that's a router. You can see the router DSL here. And we are going to specify various request predicates. You can combine them with operators. So that's an infix function. So that's just an end function, but you are using the infix qualifier in Kotlin to make it possible to call that without parentheses. You can put any and or not qualifier to modify the logic. You can directly put. So that's an invoke extension on string that was shown on Gradle talk also. And you build your So that's the roots. That's the handler implementation. You can also just use method references. So if you want to split things, and I think for big application, that's better to do that, you will put the router here. So you can put as many routers as you want. You can do a single monolithic one. You can create multiple routers. Usually, I split routing and handlers, okay? So I do this kind of thing. You see that we support nested routes. You can put as much as nested level that you want. That will also affect the way that routes are evaluated. And for the handlers, you can see that that's just pure functions that take server request as input and return a mono of server response. And we provide an API to do a view rendering. So that's not just about REST web services. You have the same level of functionality than Spring MVC for view rendering. Expect that we support asynchronous and reactive model attributes. We support regular REST web services. We support server-sent events, also WebSocket. So, yeah. So that's a way I usually use functional web API in my Spring Boot application. Be aware that we also support functional bin registration, so you are not forced to use that. It's a matter of test. Functional bin registration is interesting because in addition to the format that's very efficient, no reflection, no CGL proxy, no annotations. And so that looks like that. That could be seen as a kind of a trade-off between XML and Java config because that's code, that's Kotlin code with a DSL, but that's just regular functional code. And it's both declarative and programmatic. That's declarative because that's just a declarative way to declare your bins, like in XML, but you can add any if for expression to modify the registration logic. You can see that the router API plug quite well in the bin one. So here you see I declare the bin DSL with that. I declare various bins. Here I just have to specify the type of the bin and it will be automatically auto-wired. Here I'm providing directly the implementation and instantiation of this bin. And thanks to Kotlin type inference, we avoid repeating the same code in Java. Will be much more, much bigger. And you can see that I can, in a bin declaration, I have this is the equivalent of a Java config method parameter when I have a bin A that have a dependency of the bin B. So here, for the router, I need a dependency on the user handler, and I just call ref user handler that will provide a reference to the user handler. And inside that just leverage our Spring regular infrastructure. You can also, in the DSL, there is various things. For example, you can put conditional bins using the profiles or any environment. So here, I'm providing a lambda that must return true or false. And here, I just want to initialize my database when I am not on my Cloud Foundry instance, for example. So you can use this kind of thing to describe your logic with various predicates. So this bin DSL can be used standalone or integrated with Spring Boot. And with Spring Boot, the best way to use it currently, maybe we will make that more easy later, but that's not super complicated. Basically, a bin DSL is an application context initializer, which is a type which existed before. And you just create a class calling the various bin DSL. So in my application, usually I create various contexts for web, for database, to be able to enable just one of the two or the two to be able to control that. And I reference that as context.initializer.classes. There is another way in the run application lambda that I have shown before with the banner, but the issue is that it will not be taken in account for tests, so I prefer this way. Even if the run application syntax is more sexy, we will try to see if we can make things better later. I will finish by Kotlin, with Kotlin for the front end. So an interesting use case, I think, is to be able to use Kotlin in the various places in your application to limit the amount of technology that you have to learn. And so it's possible to use Kotlin for front end. So this is a simple JavaScript code. I don't use any fancy library like Angular or Ember or React. I'm just using plain JavaScript. And for server-side applications, when you are writing a blog, for example, that's perfectly fine, I think. And I'm just writing that to be able to leverage server-side events plus the support that we have in Spring Data MongoDB for tailable cursors, which allow to create streams that will push notification where there is a new MongoDB document created. And I use that to, via server-side events, to be able to call a notification that will display on your desktop from the browser. So that's the JavaScript code. And in Kotlin, that's barely the same amount of code. But the big difference is that you have a single language to learn that's type safe. You can use extensions. You can use data classes. It has full null safety. There is a few things that need to be improved. For example, events are not statically typed, so I hope this issue will be fixed. Kotlin teams, if you see that, this issue is important. And I think that's pretty nice. A blocker for a very long time has been the size of the JavaScript code generated. And since 2 years, I said to the Kotlin team, OK, it's nice, but it generates 2 megabytes of JavaScript. And I don't want that for my blog, sorry, or for my site or thing like that. So that was a showstopper. But the Kotlin JS team has done a very good job with the new dead code elimination tool, which is available in current Kotlin 1.1 release. And it does a pretty good job to remove all the unused code. So with this application, I just have 10 kilobytes of gzipped JavaScript size. That's super small. That's even smaller than a lot of JavaScript libraries. So just using plain DOM APIs with Kotlin JS and the dead code elimination tool is super easy to set up, and I think that's a nice thing. For the long term, I really think that JavaScript interoperability is not the way Kotlin will be super successful with the front end like it is in the mobile and hopefully like it will be on the server side. So I really push for a WebAssembly support, which has been announced yesterday, even if it's still the early days for that. So WebAssembly is basically a native platform for the web. If you don't know that, go to read this super nice intro by Lynn Clark. It's really explained very well what it is. It is already supported by the 4 major browsers. So I'm not talking on something that does not work. It currently works in the 4 major browsers. There is some missing part like DOM API or garbage collectors. There is some missing parts that are coming. But currently, it's native for the web. And the idea is to build Kotlin could use that as a compilation target, much more optimized compilation target, to be able to develop a front-end application. I think that's much more suitable than JavaScript. That could be a very good compilation target for performances, low-level consumption of memory, and it's a place where a whole new front-end ecosystem could be created. In JavaScript world, we have to use all the JavaScript tooling. That's a lot of things to set up. Here, that's a new place. There is nobody. Maybe next year there will be Swift, Kotlin, or any other languages like Rust. So I really think that's the only chance for Kotlin to be super successful on the front end on the long term. But JS support is nice for now. So thank you for your attention. I would like to thank you, all the people from the Kotlin team and from the community, and also in the Spring team, because I bother a lot of Spring developers with Kotlin support, and a lot of Spring developers are really keen on Kotlin now. So thank you, everybody. You can follow me on Deleuze for some news. And everybody that I have shown came from these various repositories. So feel free to have a look, to have a concrete example, clone it, submit pull request. And if you want some Kotlin Spring features, extensions, create issues, submit pull request, and that's open. Thanks.